Hello, everyone. I'm Kohsuke. I'm the co-CEO of the Launchable Inc., which is a new company I started several months ago. And today I wanted to talk about the GitOps and Jenkins X and future of CI/CD. So DORA, this research institute, publishes the State of DevOps report every year, and then in which they depict a picture of the software organizations trying to get better at the software delivery, in which the primary author, Nicole Ferguson, she describes this picture of where companies are all trying, but some of them are getting better and better, while others seems to be falling behind farther and farther. And this is because the software delivery is an exercise in continuous improvement, meaning the effect compounds. And I'm sure many of you are here because you're precisely, feeling this effect. So this naturally, this resonates a lot with how I feel when I go talk to the software development teams around the world. So naturally, I got interested in, why this is the case. So I think that one of the key struggle is that there are two competing factors, seemingly competing factors that organization need to satisfy. The one is the throughput, meaning speed in which the changes are the amount of the changes being delivered, and also the stability, meaning making sure that the production is up and running and your customers are checking out the product happy, that sort of things. So the typical challenge is like we all want to increase the amount of change, the throughput, but then it tends to have this negative effect on the stability. Well, so that makes people feel like, well, we can't really have both. That sort of like it's this like a dead end. People feel like they're trapped in this dead end. But really, I think when we look at what's going on in the world, in this technology world, the difference between these organizations that's moving faster and moving slower is how they can embrace these two goals at the same time, instead of seeing this as either or. So, and in the meantime, unless you've been hiding under rocks for the past few years, there's this new cloud operating system, which is how I think of it, is here, right? That is the Kubernetes. I think there's a lot to like about that. The fact that it's a common platform across all clouds, so you can control the amount of the lock-in to this environment. It provides a number of useful functionalities, the cluster scheduling, service discovery, load balancing, etc. But perhaps, what I really like as an engineer is this notion of extensibility baked into the Kubernetes so that additional functionalities can be developed and added by other people on top of this platform. And then collectively, the whole thing still, feels and behaves like one platform. So in the face of these, new capabilities, everyone seems to be rebuilding their own DevOps flow, right? Like how the change flow into the productions and that feeds back into the software development cycle. But I want to I want you to pause and think about this because I think, in some sense, this is the new legacy that these DevOps flow, building it is hard enough, but, who is going to maintain that, right? Like when you join a new company, you feel like there's all these slightly different ways of how, the changes flow to the productions. And it tends to become this snowflake that only a few people know how they are all put together. So the moment you create these things, it sort of start to get stale and you need to constantly maintain them, which I don't think is really what you want to be spending time on. So if building your own DevOps pipeline or delivery process is not important, the better question to ask is, what is important? And I think that's what that's why the industry is leading to the notion of GitOps. So just to kind of recap from the starting point of what the GitOps is, the idea here is that the Git repository behaves as the central repository of the truth, that is the representation of the desired state. And on the left-hand side, people employ the same workflow they use for the software itself to control the state, right? So like things like, validation, pull request, code review, that kind of things. And once the change gets into the Git, and there's this right-hand side of the things, which is there's this system that's in place to continuously update the runtime system into this desired state. Like it's a convergence-based system. So this automation kind of happens behind the scene. And then this interface between the human activity on the left and the automated activity on the right kind of is, well, that interface is through the Git repository and textual representations in it. And so that's the key idea of the GitOps, at least the way I think about it. So why are so many people latching onto this? Well, there's a lot of reasons to like here. For example, I think that one of the key reasons is that it provides transparency without sacrificing the auditability or the access control. And then in many software development places, these things do matter. They operate in the industry where these are the legal constraints. So, you don't necessarily have to control who gets access to, making these changes, but you can still making sure that the right, the approvals and checks and balances happen before change gets materialized. So everyone else can see what's going on, even if they might not be able to change them. GitOps is also tool agnostic, like it works with any of the infrastructure as code kind of tool, not just Kubernetes. And it promotes the higher level of abstraction and use through the templating and other, other higher level libraries. You can review and test the changes before you merge them. It's quite trivial to roll back the changes. You can see what changes has happened, going through the Git archive, and really employ the same similar workflow that you are used to in Git and GitHub, and that every developer is familiar with. So, all of that is great, but still putting this all together in the face of the new platform like Kubernetes, is a lot of work. Right? It's you need to learn new technologies. Installing, operationalizing Kubernetes is not easy, actually. And then you have to survey this rapidly changing ecosystem and pick up the additional tools and services that you want to combine and assemble into a functional delivery pipeline. You need to move your application to the containers if you haven't done so. You also need to figure out how to deploy containers to Kubernetes. Are you going to do this, the YAML files or the Kubernetes resources, or like a Helm? You need to wire up all the automations so that something happens after the push to the Git repositories on the right branch. And all the while, figuring out the best practices, how all these delivery pipelines should work together. What is this GitOps things? How do I deal with all the secrets that's necessary in the runtimes? Am I doing the right? And even if you put them all together, you're still left wondering, are you doing the right thing? It seems to be working for you, but does that mean you have chosen the best practices? You never know what you're missing out. And so that, I think, is a key challenge of trying to tame this kind of beast. And as an engineer, I get the fun of it, right? It's got the same feeling as opening up the bonnet of a car and try to tinker with the engine. And it really is fun. At the same time, is that what's the most important things that you need to be working on? And I'd claim that's not the case. Right? So that's why we are working on Jenkins X, the new project from Jenkins. Right? The key idea here in Jenkins X is that we figure out the best practices of how to do continuous delivery for the cloud native applications. The idea is and here when we say continuous delivery, I'm not just talking about the build and test, but it encompasses the entire thing from the code review all the way to the build and test and merging, promoting to the different environments, the creating the change logs, collaborating with other people, and it spans the entire thing. So and we do that by integrating the best of the breed software in this ecosystem. Right? You might not be able to keep up with all that's happening, but collectively, as a community, we can and we should be able to. And then, we hide all these things behind a pleasant command line interface that acts as a primary interface between you and your developers to all the systems behind the scene, and it represents this higher level abstractions, the conceptual level that you're manipulating things, and it translates things into this like lower level actions that needs to happen on these automated systems. And then in order to do this effectively, Jenkins X is opinionated in how to do things. In fact, that's a key part of how we can make things high level. And then by doing all of that, we can push the Kubernetes down into where it really belongs, which is a means to the end, which is to deliver software faster for your business. So, I often describe the difference between Jenkins and Jenkins X in this way. So Jenkins, the classic Jenkins, is like a vast road network. Like it spans the entire continent in the sense like everyone is doing software development a little differently, and where they are in the journey and their goals are also kind of unique to each organizations. So it's the classic Jenkins. You're in the driver's seat. You're driving a car to your destinations. You can make, you got to take your own turns at the right place. But there's quite a bit of flexibility. You can choose your destinations. You can even change them as you go. Now, in contrast, Jenkins X is like a high-speed rail network. So it really only goes to one destination. That is the cloud-native web application development, and that is the most, but this is a very popular destination. A lot of people are trying to go. So, with Jenkins X, you just need to show up in a train station, and the next bullet train will come, and you just need to hop in and then sit back and relax, and let the train take you to the destination. You don't need to be in the driver's seat. You don't even need to know exactly where it is. We take you there. So that I think is the sort of a key difference between Jenkins and Jenkins X. Now, I mentioned that what we do is opinionated. Right? The good news is that the opinionated development flow that we preach shouldn't really come across as a surprise. So the kind of the mental picture we present is that everything maps to the Git repositories. So your app and the source code, your app deployment, all of that is in different is in Git repositories, and then you use your branches to develop them, and then that turn into the pull requests coming into the master branch. And then you promote those through different environments. Different branches track through different environments, and you promote those bits through different environments by merging those branches. Right? So again, I think this is a practice that many teams have already been doing. And then the whole point of Jenkins X is to kind of codify that and build all sorts of automations around these best practices. So, the other parts of the best practices we preach is that we use the idea that we should be using cloud more for the development, so that we can keep your laptop for what it needs to do, right? So let's not run all the services locally in your own computer, and guzzle up all the RAMs or none of the crazy stuff like that. And then we also, the promote this practice of keeping the master branch always releasable. I think is one of the key ideas and spirit of the continuous delivery. And we also encourage folks to deploy often in smaller increments. So we turn releases into smaller events, not like a big ceremony. And we can also help you inform other people about what changes are. And that's important, to coordinate your changes and keeping the visibility for the other people who depend on the stuff that you're working on. So, like once you start using Jenkins X, what we hope you find is that all these best practices that we are preaching are in many ways boring in a good way. And I mean, I think of this as a good thing, right? Like we even be showing you some earth-shattering, groundbreaking things you need to learn from scratch, but rather like once you pick up the Jenkins X, you feel surprisingly at home because none of these things are new to you. But they're just combined in ways and automation built around it to make you productive. So, behind the scene, there's this, in order to do this, we put together a number of the existing software into the mix. So, Jenkins X contains these the pieces like Helm and the webhook receivers, the image repositories, and Tecton and other kind of stuff to implement those set functionalities. But again, the key point is like you don't need to be aware of all this stuff. So another thing that makes Jenkins X worthwhile, it supports all sorts of different cloud, including the major ones, like Azure, Amazon, and Google. But those are not the only ones in the mix. And then with a simple operation of JX create cluster, we can create a new Kubernetes cluster if need be, and deploy all the necessary software on top of it, and then make the environment ready for your action. So to give you the feel of what it's like to drive Jenkins X, so let me walk you through what it's like to use it. Right, so imagine like the starting point is like you have a computer that's fresh and empty, right? So the first thing you do is like you can install the Jenkins X through the homebrew. So you do that, and then you run this JX create cluster, which after a little bit of the dialogue, it asks you, things like your GCP credentials and so on, and you get all the tools, pre-configured and wired properly. So it contains the Jenkins as a build agent, artifact repository to speed up your builds, monocular to catalog Helm turrets and other things to make this thing function. It also, by default, gives you this staging and production environments mapped to the namespaces, and for all your future applications to be onboarded in Jenkins X, we're going to run in this environment. So these are sort of like a mundane pieces in some sense that you have to have before you can get any of your app going. And those are the parts that we took care of that by you're just running one command. So then the next step up is to bring your application on board. So you can either create a brand new project by running commands like JX create Spring. So what this would do is to initialize give you a new skeleton code. Or if you already have existing applications, you can make it work with Jenkins X by running JX import on top of it. And then it's going to sniff the workspace and add some necessary additional files that's going to wire this up into Jenkins X. So in both of these cases, what happened was that you ended up in the source code. Well, either we created one for you or you already have it. And then we also add you the wiring necessary for building, deploying, and continuous delivery. So Docker files, Helm templates, the build script, the build pipeline, that sort of things. And then we also provision the necessary services. So, as a part of the prompt, we can even create a new repository on GitHub for you, set up the webhook, set up the automation job, and all of that stuff. And then, the initial, by the act of, because it wires up all the automations, by the act of the initial release, by the act of initial push, Jenkins X, it's going to, produce the initial release, and it's going to auto deploy that into the staging environment. And all of that happen as a result of this, just one command. That's neat, isn't it? So what you'll be doing more often is to work on a change, right? And then this part doesn't really change. Like you use the same familiar tooling, whatever IDEs, text editor or whatnot, to work on the change to develop that locally, and then they push that into a branch, and you can create a pull request on the GitHub, and then you have that change reviewed and merged into the master branch. What Jenkins X adds to the mix is just all the automation that automatically happens around this familiar workflow. So for one, your pull request gets automatically built and tested as soon as you push that into PR. No additional configuration and wiring necessary. And this app that you have in your pull request gets deployed to this specific preview environment on this Kubernetes cluster. So your stakeholders and other people reviewing the code can not only get to see the change in the source code, but they can actually interact with these running applications. There's a link provided into the PR as a comment by the bot, and then so they can easily navigate that to make sure, let's say, the design change is looking good as intended. And then when you merge the change to the branch, to the master branch itself automatically also gets built and tested. And the new release gets created from the master branch automatically with the appropriate change log covering everything that's listed. And then that gets auto-deployed into the staging environment because the default configuration is a staging environment tracks the master branch and auto-deployed. So when time comes to promote this version into a production environment, you'll be running a command like this from somewhere, like JX promote. And what you're essentially telling Jenkins X is that, the directory where you're running this dictates what application you're talking about. This application version 003, you want to promote that into productions. So, this command is a little bit deceiving because it makes you feel like this is doing the act of promotion by itself. But remember, this is GitOps. So what this command actually do is to check out the separate repository that controls the state of the production. And then it makes a change, the update in the file there that says, this application's version 003 is what should be running in production. And then it makes a commit and it creates a pull request against this repository. So at that point, whoever gatekeeping the entry into the production can see that, oh, there's somebody proposing to deploy a new version of this application to the production. And then they can go, GitHub and merge this deployment PR. And then this act of merging triggers the other set of automation, which eventually leads to the deployment of version 003 into the production. Right? In other words, again, the GitOps workflow implemented and then delivered without you putting any of these things together by yourself. So I hope this gives you the key idea behind the Jenkins X, and then that's what I think makes Jenkins X really powerful, is that all these things happen automatically, and you get to keep the same familiar workflow. So here I switch the gear a little bit and start talking about the future of CI/CD. Now, talking about the future is always a fool's errand because you're going to bound to make a fool of yourself. But what I mean by the future of CI/CD is really, the interesting trends and things that kind of excites me in the space, and so naturally this leads to some of what I'm working on. So, I discussed earlier that many organizations struggle to meet these two seemingly conflicting goals: the throughput of the change and the stability of the production environment. So, GitOps is a necessary mechanism, I think, to contain, to attain this piece, but I also don't think that is not sufficient by itself to achieve the higher velocity. So I think one of the key, in my mind, undeniable trend that's going on in the space is to defend stability through depth and then not just rely on the tests. because the prevailing mindset of the previous decade, perhaps, is that it is a test that stands between the developers' fat fingers and their innocent mistakes and production failures. So some of the it's like a paradox, or the failure is, as a project develops, like matures and develops further and lives longer, they tend to amass more tests. And then and then tests have all sorts of challenges. And because of that, like at the time it takes to run all the tests and so on, gonna skyrocket. And then it really gets in the way of having throughput and like a faster delivery. So, I think, well, tests obviously are still important, perhaps more important than ever. But I think there's this effort not to just depend on the test, like accept the fact that the production, some regression will creep through and try to contain the damage in the production when that happens. So, like practices like feature flags and circuit breakers and canary deployments, all of these efforts are designed around this idea that you can change the behavior in the production quickly, or like when some bad things happen in production, like the failure doesn't cascade through the system, or accept the fact that the change is risky fundamentally. So you roll that out slowly, and for the first sign of the trouble, you revert the state back, or at least the damage is not going to be widespread to every user, only contained in the smaller corners. Right? So all of that is built around the idea, like assumption that the changes that you're going to deploy will break from time to time. So I think this trend obviously is going to continue. Another thing I think is more amorphous approach to testing. Right? So like most of the developers kind of instinctively feel like the tests are only going to give you so much confidence because the situation in which the tests run is different. There really is nothing like production. So I think the more successful organizations seems to be leveraging the production more in order to build confidence. And then this comes in many forms. For example, one is around the mirroring the production traffic, copying them over and like replaying them against the staging environment or some similar places, so that you can observe the behavioral differences between those two places. A/B testing is a kind of another mechanism to leverage production traffic. Right? In this case, you're actually serving your customers, at least a small number of them, from different places, and observe, like using your observational, like operational metrics or even business metrics in order to track them. So they do not produce like the kind of binary answers that the test would, like a yes or no, pass or fail. So the interpreting the result needs more nuances, but I think it's pretty clear, like they grant some insights that otherwise impossible to gain. So that, I think, this is another sort of a key technique to master. And then, so that when I think about this, and this is part of what I think makes this the DevOps, like effective DevOps, difficult, is these practices are a little bit like riding a bicycle, in the sense that well, until you have like a sizable enough traffic, you're not going to be able to use these techniques. So let's say if you're working on a new product, well, then you can't really do that. So early on, you will not have enough confidence, and then so you'll be scared to deploy. You lean on testing, like you lean on like a slow release cycles. But at some point, as the things start to pick up the pace, you need to start. The bicycle becomes more stable, and these practices become more adaptable. And then so this sense of, well, like previously you have so many tests, and you lean on like a manual testing or like a soak period to get deployed. And to go from here to this new world of, well, I have these other means to build confidence. So like we do not need 2 weeks manual soak testing time, or we cannot afford to. That is a like a mental mindset change that's often difficult to adjust, fundamentally uncomfortable. So Now, another things, in the beginning I mentioned that the key idea behind the continuous delivery is this continuous learning. So, if you incorporate the learning into your way of work, then it sort of becomes obvious that the machine learning has a lot of opportunity to make a difference. And then some companies are already doing that. So this is the sort of what gets me excited the most nowadays. So, let me give you a few examples. So, I talked about the testing. So the smarter testing is one of the things I'm seeing in some places, right? So imagine yourself in this place, this like a large company in the DevOps team. You have a massive modularized code base, but it is a massive code, so there's a ton of dependencies. It's a complicated beast. So, and in this company, this project has been hugely successful business-wise. So what that means is like you have a code base that's evolved over 10, 15 years, and that you amass that much, testing. So it takes a lot of time to run those tests around this code base. So, so you see like thousands of developers working on this code base, millions of the test cases around. So, like the time it's taking to run these tests are becoming prohibitively expensive, not just time-wise, but also cost-wise. So how can you cut this cost and time to deliver this software? So the step one of what this company did was, the one that's based on the dependency analysis. So imagine you have these individual files. Those are the diamonds that I drawn at the bottom of this graph. And then they kind of come together into modules. And those are the squares in purples. So the modules depend on each other, so they generally form like a big web. And then there are also tests that depend on these modules, right? So imagine if you have this like a graph, and this is obviously pretty small, but in a successful flow effect, this gets massive. So the step one of what they've done is, from this kind of dependency analysis, you can tell that if somebody touched a file that corresponds to the very bottom left of the graph, then you can statistically infer that there's only one module that you need to rebuild and two tests that needs to be run. Everything on the right was not modified, and therefore you don't need to touch them, right? So this obviously, this is the first step that gives you the cut. But in some sense, this is not what I want to talk about. Well, actually, let me point out that I come across so many organizations that they don't even do this level of incremental build, right? They simply just rerun them all, rebuild the master branch, rerun all the tests. So that's kind of how that's the sorry state of the world today. But what's amazing is actually the step two that they took. So, their organization, their code base was so big that even this kind of dependency-based analysis wasn't creating a small enough subset. And to help you understand this challenge, the key problem is that the integration tests, these are the ones that tend to touch a lot of things. So, and then they are also the one that tends to take the long time. So, as the code base gets bigger, no matter where in the system you touch, you almost always end up impacting these integration tests, at least dependency-wise. So what they did was they trained a machine learning model that predicts a useful subset of the tests to run, based on the information about the change. So yeah, the static analysis doesn't eliminate the need to run all these tests, but instinctively as a developer, we know that not all integration tests are sensitive to changes in every part of the system, right? So the idea goes, well, we should be able to learn these things. Well, we, the humans, might not be able to, but the machine should be able to. So in this company, there are thousands of developers producing, 10 to the power of 5 changes. So that's, the hundreds of thousands of changes per month. So even if you pull out just 1% of this data set, they found that that was enough to train a viable model. And then it has some pretty impressive impact. So what they are able to do is to cut down the amount of tests that gets executed to just 1/3. And whenever you run the smaller amount of tests, the thing that you worry about is like you might be slipping through some regressions, but they reported that despite the fact that they are skipping 2/3 of the tests, they're only missing about like a 0.1% of the changes. And then by doing that, they were able to cut the infrastructure cost by half. So you can imagine at this scale of build and test, they are spending a lot of money. I believe in the millions per month just to run this environment. So to be able to cut that in half must have been pretty impactful things. Like imagine how many engineers you can hire with that kind of money, right? So that's what they've done. And then this this problem and this solution kind of got me so fascinated that this is the problem that Launchable we are working on right now. So I'm looking forward to talk to other people who are thinking about these kind of things or challenging these kind of problems. So here's another example of the machine learning deployed to solve real software development challenges. So this time around, imagine you're the SRE team, right? So you are in a big company working on, responsible for your production environments. So this company is already pretty ahead in this microservices development mode and continuous delivery. So this SRE team was overseeing like hundreds of applications that's landing. And each of these apps on average was deploying once a day. So I'm just going to point out just like how awesome this is already. I don't think most of us are at this at this level of sophistication just yet. But anyway, you can also imagine like if you're in the SRE team like setup in a setup like this, then literally hundreds of deployments are happening every day on the services that you can't even count. So you're gonna feel real uncomfortable, right? Like you're on the hook when something bad happens, but there's just so many changes landing in, and you have little sense of what's going on. So the question they ask themselves is like, can we flag any risky deployments beforehand so that you can ask for the adequate support system, or when the bad things happen, like can this information be used to sort of assist the troubleshooting process? So again, so what they've done is they looked at the 40,000 deployment records, I believe over about like a year, of which about 100 of those were deemed failure. So they either created some alerts or they got rolled back substantially. And then they looked at the attributes of these deployments, like what code changes have been, the application names, and the messages of these commit messages, etc. And they're trying to predict this failure, right? And then they reported that they were able to produce a model that predicts like a 99% of the failures at the rate of the 5% false alarm ratio. So that, I think, this is actually like a pretty astonishing accuracy. It's almost hard to believe. But they reported that with this kind, this made a huge impact. And then two, like they were able to learn interesting and useful things. So, for example, the previous mechanism they deployed before they switched to machine learning model is to ask the developers what they thought, whether this deployment is going to be low risk or not. It's like a self-certification process. So, and then based on this machine learning model and this data analysis, they learned that this flagging by the developers turned out to was not very useful. And two, when the approvals previously, when the time it took for the approvals was short, the shorter deployments. Well, let me do this again. So the deployments that was rushed tends to be the one that created outages, which also makes sense. And then the third, the long maintained code base tends to be more risky. So again, this also makes sense. But what's actually great about these is that not that they discover these things. Well, in many ways, like that's quote unquote obvious. But what's amazing is it can put the numbers around these things. So, for example, like imagine you can tell your management that the past 2 years, like every month the code base lives longer, it increases the likelihood of regression by like 3%. And they'd be able to convert this kind of number into the actual business impact. And that would suddenly do all sorts of wonders in your justifying, that refactoring or rewriting that you knew you had to do, but previously, like a non-boss would be very forthcoming about spending time and effort into these things because on one hand they get it in theory, but they can't kind of compare that with all the other high priority things that they wanted or they needed to do. So so you can, this kind of numbers, the data has a way of rallying the organization around you in ways that otherwise difficult. So I think that's a pretty like a powerful tool that they unlocked by doing this. So, and then they are talking about how to use this information as the next step to, for example, ask somebody from the team to be on virtual call available to troubleshoot if the problem happens, or some of these higher risk changes, you can't really deny the deployment, but you can certainly constrain when they are allowed to deploy. So, no more Friday 5 p.m. deployment if you are deemed high risk, that kind of things. So, this kind of was, if I step back, one thing that I want to point out is that those two examples that I shared, they both came from these large organizations who are already pretty successful, right? Like the second one I just talked about, like they are already deploying like one a day across hundreds of apps. So that's probably like 95% percentile of the DevOps transformation, like better, like a top 5%, I would say. So I used to think, these large organizations are like the Goliath, like these large behemoths, like slow to operate, slow to change. And then so we, the developers, we like to think like a smaller company, smaller, nimble, elite teams could act like a David as opposed to Goliath, and then move more quickly and then make a bigger impact in a shorter amount of time. But as I was looking at these actual examples, I felt like, well, maybe that is not the case anymore. These companies are already at the pretty far end of the game, and they rely on some of these techniques that require a certain size to be able to even mount, and they gain and they unlock like the next level of the productivity. And so this seems to be, creating a wider gap. Maybe your industry is becoming like a manufacturing where the scale of economy kind of trumps everything else. Well, that I'm not sure if I'm ready for that kind of future, but maybe that is what's happening around us. So that got me thinking a little. So yeah, that brings me to the end of the presentation. So to wrap up, every organization is trying to get better at the software delivery, and the Kubernetes is clearly an enabling technology, but it can also be a detractor because it's so fundamentally like engine and requires integrations. So in that world, what really matters is the developer experience, like how your developers interact with this invisible automation, and that is the GitOps pretty clearly. I think that is a consensus. So Jenkins X brings that GitOps to Kubernetes that you're rolling your own software development cycle and creating a legacy. And then CI/CD is continuously evolving, and then so is Jenkins, and that's what led to Jenkins X. So on that note, thank you very much, and let's switch to questions, I think.
Kohsuke, thank you for the speech, and now we have some time for questions. Let me check if we have anything in our chat. Guys, please don't be shy, add your questions to the chat and I will read them. And I would like to remember that after the questions from chat, you can join the Zoom conference and talk to Kohsuke personally. And the first question is from Alexandra. What are you currently working on at CloudBees?
Okay. So I'm not actually doing any active work with CloudBees. I'm an advisor, so I occasionally have some interactions, but that's it. The other thing that I described in my talk, it keeps me busy.
Thank you. So, any more questions? Okay, it looks like there is no questions in the chat, but I hope that there will be more questions personally in the Zoom conference. So, Kohsuke, thank you once again for joining us today, and please join the Zoom conference now.
All right, thanks.
Thank
I'll see you
you.
there.